Alright, so in this video, I'm going to solve the problem 2 to the power of 22 times 3 to the power of 33. So to solve this, I'm going to first rewrite 2 to the power of 22 as 2 to the power of 2 times 11. And I have this times 3 to the power of 3 times 11. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So this turns into 2 to the power of 2 to the power of 11 times 3 to the power of 3 to the power of 11. Now 2 to the power of 2 is 4, so I get 4 to the power of 11 times 3 to the power of 3 is 27, so 27 to the power of 11. And now if I have something in the form a to the power of m times b to the power of m, this is equal to a times b to the power of m. So this turns into 4 times 27 to the power of 11, which is equal to 108 to the power of 11. So this is my answer. Alright, so in this problem, I have 4 to the power of x is equal to 8. So obviously here, I want to find the value of x. So for my solution, first start by rewriting my problem. So I have 4 to the power of x is equal to 8. Now 4 here, this is the same thing as 2 squared. So I'm going to rewrite this as 2 squared to the power of x. All I did was replace 4 with 2 squared. And now 8, this is the same thing as 2 to the power of 3. So I'm going to replace 8 with 2 to the power of 3. So I have 2 squared to the power of x is equal to 2 to the power of 3. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x, that's going to equal 2 to the power of 2 times x, which is simply 2 to the power of 2x. And now this is equal to 2 to the power of 3. And now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. Meaning in this case, 2x is equal to m and 3 is n. So I have 2x is equal to 3. And this is a simple equation. All I have to do is divide both sides by 2. So then these two cancel out, and I get x is equal to 3 over 2. Alright, so in this problem, I have x to the power of x plus 1 is equal to x. So to solve this, I'm going to start by subtracting x on both sides. So then these two cancel out, and I'm left with x to the power of x plus 1 minus x is equal to 0. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So x to the power of x plus 1, this is going to be equal to x to the power of x times x to the power of 1. Now I have this minus x is equal to 0. Now if I factor out x, I get x times x to the power of x minus 1 is equal to 0. So now this gives me two equations. I have x is equal to 0, and I have x to the power of x minus 1 is equal to 0. So x equals 0. This is already a solution. Now for x to the power of x minus 1 equals 0, I'm going to add 1 on both sides. So then these two cancel out, and I get x to the power of x is equal to 1. Now, because x has to be the same number, we obviously know that, well, what number to the power of itself is equal to 1? That's going to be 1, right? Because 1 to the power of 1 is equal to itself. So x is equal to 1. And there's no other number that when you take the power of itself is going to equal 1. Meaning x equals 1 is the only solution to this equation. So now to check, the original equation was x to the power of x plus 1 is equal to x. So x to the power of x plus 1 is equal to x. And our first solution is 0. So if I plug in 0, I get 0 to the power of 0 plus 1 is equal to 0. Now 0 plus 1 is 1, so I have 0 to the power of 1 equals 0, and 0 to the power of any number is itself, so I get 0 equals 0. Now to check for 1, I get 1 to the power of 1 plus 1 is equal to 1. 1 plus 1 is 2, so I get 1 to the power of 2 is equal to 1, and 1 to the power of any number itself, so 1 equals 1. Alright, so in this problem, I have x to the power of x is equal to 100. So I'm going to first start by taking the natural log, or ln, on both sides. So I have ln x to the power of x is equal to ln 100. Now, if I have something in the form ln a to the power of b, I can move this x1 and b to the front. So this is going to equal b times ln a. So for ln x to the power of x, I can move x to the front, and I'm going to get x times ln x is equal to ln 100. Now ln 100, that's the same thing as ln of 10 squared. So I get x times ln x is equal to ln 10 squared. And if I have something in the form ln a to the power of b, again, I can move 2 to the front, so I get x times ln x is equal to 2 times ln 10. Now, there's something called the W-Lambert function. And if I take the W-Lambert function of something in the form a times e to the power of a, this is going to equal a. So this is basically what the W-Lambert function is. So if there's something in the form a times e to the power of a, that's going to equal a. So what I'm going to do over here is I'm going to rewrite x here as e to the power of ln of x, because the e and ln cancel out, and this results in simply x. So I'm just going to rewrite x as e to the power of ln x, and I have this times ln x is equal to 2 times ln 10. And now this is in the form a times e to the power of a. So now if I take the W-Lambert function on both sides, this results in ln x equaling w of 2 times ln 10. And now if I take e to the power of both sides, I get e to the power of ln x is equal to e to the power of w of 2 ln 10. And e to the power of ln x, that's going to equal x. So I get x is equal to e to the power of w of 2 times ln 10. And this is equal to 3.597285, which rounds up to 3.597. So this is my answer to this problem.